Okay, so let's give you guys a solid revolution problem. So we are going to rotate this area 360 degrees along the y-axis from 0 to 1. So when you rotate it, you're going to get a 3D solid looking something like this. You're going to get a 3D solid. So rotate it along the y-axis. So work out the volume of this 3D solid. Use the cylindrical shell method. Okay, so press pause and have a go. Okay, so to do this, we are moving along in the x direction, even though we're rotating along the y-axis. So the thickness of this is dx. And as we're moving along, we need to know, once we've got the height is given by this. Once we've got the height, we need to 2 pi r it. We need to get the circumference. So really what we're doing, the solid, the volume is given by this. From 0 to 1, we're moving in the dx direction. We're moving in the dx direction. Each step of the way, we need to know the height. So we need to know the height. The height is given by this, which will be x root 1 minus x squared. And once we've got the height, we need to 2 pi r it to get the circumference. So that will then give us our cylinder. So once we've got the height, we need to 2 pi r. R is this radius here, which happens to be x. So we're moving along here. The distance from here to here is given by x. So we need x in here. So the volume is given by this thing here. Okay, so I'm expecting you to be able to get to this stage by now. So we've done this in the past. So I'm expecting you to be able to get here. Anyway, the volume is given by this. The volume is given by this. So now it's just a matter of integrating this. So hang on. We are integrating from 0 to 1. So this is a constant, so we can take it out and then merge these two x's together. That will then give us this. Now use trigonometric substitution. So your eyes should zoom into this bit here. Create your triangle in such a way that this will be true. Well, if you make the hypotenuse to be 1 and the opposite to be x, then the adjacent will have no choice but to be square root 1 minus x squared, which is this thing here. So now we can, well, if you look at this, sine theta equals x. So we can obtain our dx by differentiating it. So dx is given by this thing here. So later on we can put this into the dx, and looking at this, we need to extract this from the diagram. So if you look at this, cos theta equals adjacent over hypotenuse, which is this thing here. So we can put this into this square root thing, and then we've still got our x squared. So let's look at this. X equals sine, so x squared equals sine squared. So we can put sine squared into here. That will then give us this. And remember, we are integrating with respect to theta. So it's x equals 0 to x equals 1. Later on, we will translate all the thetas back into the x, so we can make use of these later on. Okay, so I'm just going to ignore these for the time being, and then evaluate everything, and then later on, right at the end, I will put x equals 0, x equals 1. So let's try and integrate this. So tidy this thing up. That will then give you this times this. So now it's just a matter of us evaluating this. So hang on. Now, when you get to this stage, there are lots of ways of working this, of integrating this. Use whichever way you want. For me, I'm just going to turn this block into blocks containing cosine only, and then I'm going to merge them together and use the reduction formula. You see what I mean? So let's turn this into into this block, and then this stays the same. So notice that this block here contains nothing but cos. So now multiply this out. That will then give us this and this. So now that will then become this. So now we can use the reduction formula. And again, there are lots of ways of doing this. For me, I'm just going to turn this into a block of all cosines, and then use the reduction formula. Anyway, that will then take us to here. So now use the reduction formula. Hang on. Now use the reduction formula. Leave this for the time being and just concentrate on the higher one of the two. So let's concentrate on this block only. Leave this for the time being. So using the reduction formula, so you've got your 2 pi, and then you've got this thing here, it stays the same. But when you apply your reduction formula on this, it will give you this whole thing here. It will give you this whole thing here. So let's apply the reduction formula on this. So n here equals 4. So it's saying, remember, this is our minus here, this is our minus here. So applying the reduction formula on this would be, remember, n equals 4. So it would be 1 over 4, it would be 1 over 4. 4 take away 1 would be 3. And then 4 take away 1 would be 3, 4, 4. And then 4 take away 2, that would be 2. So applying the reduction formula on this, that will then take us to here. And then multiply this out, that will then give us this. Multiply this out, that will then give us a minus this whole thing here. The reason why we left this earlier was because of this. Where was I? Hang on. So looking at this, exactly the same, exactly the same. So it's like me saying one of something, take away 3/4 of that same thing. So it's like me saying 4 over 4 take away 3 over 4 of the exact same thing. So that will give you 1 over 4 of that exact same thing. So hang on. So hang on. This take away this will then give you this, and then this stays the same. And then hang on. And then let me think. And then let's multiply this. So this times this will then give you this. This times this will then give you this. Okay. So hang on. And then apply the reduction formula again on this. So applying the reduction formula, so you've got pi over 2 here, and then applying the reduction formula. Remember, this time n equals 2. N equals 2. So the reduction formula would be 1 over 2, 1 over 2, 1 take away, sorry, yeah, n equals 2, remember. So 2 take away 1 would be 1, and then 2 take away 1 would be 1. This here would be 2, and then this thing here, 2 take away 2 would be 0. Cos 0 of x, anything to the power of 0 is 1. So that's this thing here. So applying the reduction formula on this will then give you this whole thing here, and then this remains the same. So tidy this up. This times this will then give us this. Integrate this will then give you just theta. So our answer is this, but we don't want the answer in terms of theta. We want everything in terms of x. Here we've got all thetas. So going back to our diagram, from above, our diagram from above was this. So now going back to the diagram, let's translate everything. Cos theta, this is cos theta here. Cos theta is actually square root 1 minus x squared. That's this bit here. So cos theta is this bit here. And then translate sine theta. Sine theta is x over 1, which is this thing here, which is just x. So sine theta is just x. And then if you want to know theta, well, looking at this, theta equals inverse sine of x. So that will then give us this block here. So this thing here becomes this. And then cos to the power of 3. Cos is this thing here. So cos theta is 1 minus x squared. To the power of 3. To the power of 3 would actually be this, 1 minus x squared. Square root is to the power of a half, and then you cube it. So it would be this times this, which would be 3 over 2. Which would be 3 over 2. So this block becomes this, and then sine theta is x. And then now evaluate everything. Hang on. Evaluate everything. If you put 1 into here, and 1 into here, and 1 into here, and so on. Well, if you put 1 into here, this block here would be, well, 1 squared would be 1, 1 take away 1, well, this thing would be 0, making the whole thing 0. If this thing here is 0, then the whole thing here would be 0. When you put 1 into here, this thing here would be 0, making this block to be 0, making the whole lot to be 0. And then put 1 into here, it would be pi over 4 inverse tan of 1. And then when you put 0 into here, everything disappears. So this would just become this. So inverse sine of 1 is pi over 2. So your final answer, your final volume is given by this. Okay.